Okay, you see the title. You see the title. Today we're going to be converting rectangular to polar form in complex form. Okay? Okay, so first you're going to know what is the rectangular form is in a complex plane. Is z equal to a plus bi. And what is polar form? We have two forms, the polar form and the Euler form, but they are equally. So we have two forms. Z equal to r parentheses cosine theta plus I sine theta. And the Euler form is r e I theta. R to e to the I theta. It's look pretty amazing, right? Because e to the I pi is minus 1. Anyway, we're not talking about that. Yes, these are the same thing, but this is polar form, Euler form. And okay, but what is the formula to convert it? Well, the formulas is radius equal to the square root of a, sorry, square root of a square plus b square. R square equal a square plus b square. Yep. Now, is b is imaginary or real? Oh, b is real, but bi is complex, imaginary. Okay. And the angle, remember, b is real. Okay, but most of it is imaginary. The angle is inverse tangent of b over a. Real part divided by real part. So the first example we're gonna face is this one. This one I came up with myself. So okay. So this are example. Example are standard form is 1 plus I. No, square root 3i. A standard form a 1 b square root 3. Well, to make it as the polar form, just write p, and the Euler form. No, Euler form, not Euler. So the first I thought these pronoun, the e is pronounced Euler, but it's actually Euler, like boy. Okay, so this is what you gotta do. So the radius is equal to the square root of this 1. You square that. Well, this is all positive, so technically you don't need parentheses in this one. We just square root 3, square root 3, and we square that. Well, so r equal to cancel. So you get square root of 1 squares 1 plus 3, which is 2. Okay? And you don't need to, I don't need to calculate 1 plus 3 is. Come on, okay. Now, angle theta. Theta equal to the inverse tangent of b, which is square root of 3, b square root of 3 over 1. Well, square root of 3 over 1 is that, square root of 3. So the angle equal to inverse tangent of square root of 3 is pi over 3. And you can draw conclusion too. You draw right triangle. Anyway, the polar form is going to be what? Well, the polar form is going to be I should not write it in this red. Let's write in black. I don't really need to write in red now. So polar form is R. R is 2. Parentheses. Cosine theta. Theta is pi of 3. Plus I sine of theta or the angle. Same thing. Pi 3. Now at this point you can distribute right away. You can distribute out the first thing too, but let's just leave it like this. So yeah. So first P equal to 2 cosine of pi of 3. Well, 2 times cosine of pi of 3 is 1 half. Add 2 I sine of pi of 3 is square root 3 over 2. And you can see this and that cancel. This and that cancel. It just means 1 half. So P equal to, this is 1 I square root 3. You can bring the I to the left because it's just a constant. And you might be wondering, is this the same thing? Yes, it's the same thing. So polar form is the same thing too. Okay. Now, Euler form. Euler form is E. I don't really actually need to write P and E anyway, but that's okay. So first is REI theta. R is 2 e to the I. Angle is pi of 3. So E equal to 2 e to the pi I of 3. Yeah, and that's it. Yeah, this is it. Euler form and in polar form. Okay, next example. I'm still gonna leave this. We're not gonna erase this right here. Okay, so next example, I'm just gonna give it like a random off the top of my head. Z. Oh yeah, I should write in Z, not P. Z equal to 2 plus 1 half I or I over 2. Whatever. So angle. No, radius, my bad. Square root of first 2 square. 2 square. And add this square. So I'm just writing the square first. 1 half square. Not 1 square over 2, okay? That's why parentheses so you can know. So R equal to square root of 2 square is 4 plus 1 half square is 1/4. If I do the math, let me do the math real quick. It's 17 over 4. So the radius is square root of 17 over 2, or 1 half times that. The angle is inverse tangent of B, which is B is 1 half. Okay, why am I starting? Over A, which is 2. Then close parentheses. So the angle equal to inverse tangent of 1 half divided by 2 just means 1 half times 1 half, which is 1/4. 1/4. So yes, this is radius and angle. Okay. In polar form, Z equal to R, just square root of 17 over 2 times cosine of the angle, which is inverse tangent of 1/4, is approximately something that we add. Oh my god, I don't think I have enough space. Sine of inverse tangent. Okay, I don't have enough space. But let's this. Okay, this is really long, but I'll leave it to you guys. And you guys know what to do, right? Well, that is for today's video. This is too long, so I cannot write it. Oh yeah, but still I can write in Euler form. And you can draw a triangle to represent what this is. Well, in Euler form, is r, which is square root of 17 over 2 times e to the I inverse tangent of 1/4. And that is it. And I don't know why I write in red. It's because it's my favorite color. And shout out to Black Pen Red Pen. He give me the energy to do clip for you guys. That's why I'm at this 2 pen and blue pen too. He mostly use 2 pen, which is this one, this one. Sometimes you use 3 pen to take notes, like you write the note from the side. And the maximum he used is 5 pen. That's a lot, but he not holding a 5 pen. There's no way that he can switch pen. And the the video that he used 5 pen is the all-in-one calculus problem. He used this green purple. That's a lot. Purple for series, green for differentiation, and blue for integral, red for canceling, and black is the main color.